Welcome to the last part of automated management of construction materials using RFID technology. In this section, I'm going to represent a proposed system for automated management of construction materials and discuss about the conclusions. As we discussed earlier, projects could exploit different types of technologies such as identification, positioning and locating, and data transmission to trace materials from bulk prefabricated to engineered materials, from manufacturing to installation. In this section, we are going to talk about material tracking and locating situation, general requirements of a material tracking system, RFID GPS-based system, 3 phases of automated data collection, implementation process and guidelines, material management activity timeline, types of tags and information sharing, and finally, we will discuss about conclusions. Resource management is one of the knowledge areas of construction project management body of knowledge. Material management is the most important task in resource management, and material tracking and locating is a subset of materials management. There are some general requirements of a material tracking system. It requires sufficient information about the project characteristics such as mode of transport, storage and disposal of materials, site access planning, extent of pre-assembly, and local environment and climate conditions. Also, the system should be safe with a reasonable setup cost and minimum running cost, and should provide more accurate locations than manual localization practices. The system requires network coverage, wireless link distance, and data bandwidth. Meanwhile, it should be easy to mobilize, simple, and user-friendly when operating, and should require minimum infrastructure and must be portable. The system should work well when natural illumination is low, obstructions are present, and the likelihood of signal multipass is high. It also should be capable to withstand the harsh construction environment and spend minimum time for initial setup and less time for identifying and locating. Initially, the system should have the ability to automatically identify and track materials with no or minimum human input and make this information readily and easily available to answer 3 questions of what, where, and when. That what points to automatic identification and data capture, and where and when points to global positioning system. An RFID reader could record, refer, check, and update information and transfer information to an application server through a data transmission technology such as GPRS, Bluetooth, and Wi-Fi. The application server is usable for owner, consultant, contractor, project manager, field engineer, and a staff member, which is connected to a database server. Let's review RFID GPS-based mobile, pervasive, and ubiquitous system by introducing the pioneering combination of GPS, RFID, and GSM technologies. Identification segment is RFID technology including RFID readers, an antenna, and RFID tags for identifying and monitoring the objects. System positioning and material locating tracking segment is GPS technology, and data transmission segment is GSM technology synchronized over GSM network via SIM card, and the information including ID, data, and location retrieved from RFID readers and GPS is transferred to the server in the form of GPRS. In the picture, a schematic RFID GPS-based tracking architecture is represented. The system is equipped with a GPS and a GSM sensor that both connected to separate antennas. The system has a microcontroller and a motion sensor, and also is able to store data through a memory. A battery provides required energy and the whole system could connect and transfer information to an RFID reader. RFID tags could be attached to any objects such as materials, components, tools, equipment, and labels. RFID tags are scanned when they come into each reader's reading range, and information gathered from the RFID GPS-based system is then transmitted to the server. The system is mounted on gates, internal and external transport vehicles, materials handling equipment, and people. In general, automated data collection has three phases of production phase, delivery phase, and on-site phase. RFID tags transmit material location to RFID GPS integrated system. The system identifies accurate location of material by employing GPS satellites. Then GSM system could transfer information through GSM operator to modems and then the database and application servers. To implement the system, there are some processes and guidelines. First, a management team must be created at early phase of the project, and the team is to be responsible for purchasing and implementing the system. The team may be from the owner side, from the main contractor, or both of them. Second, necessary training is required for construction workers and managers to ensure successful implementing and running the system. Third, a pilot test should be run before the actual implementation of the system to identify any malfunction issue. Once a component is manufactured or material being ready for delivery, it will be attached with an RFID tag containing unique ID and its specific information. Another scenario for tagging materials and components could be conducted at construction job site. Three methods of implementation can be applied. First, portal type, that in this configuration, system outfitted with an RFID reader with some stationary antennas should be attached and installed in any certain area such as in gates and out gates of the production facility, construction site, warehouse, and laydown yard. Second, equipment type, that each vehicle, internal and external, or piece of equipment, lifting and hauling, should be equipped with a system. The system antennas, such as GPS antenna and GSM antenna, require to be placed at the higher point of the equipment. And third, the mobile type, that a portable reader connected to the system should be carried by a key worker to collect and identify tagged items through walking around or running any equipment. In the design phase, IDs will be defined, and during manufacturing, IDs will be created and attached to the material. After that, shipment and on-site status will be monitored by scanning tags regularly. Also, tags will facilitate inspection and final check. This system could be programmed to generate reports and alerts. The report of tracking information for a particular product is usually based on the product identity code. The reports include a list of materials to be ordered, a cumulative list of materials flow, dead inventory, and list of actually used materials. These alerts include a list of materials that should have been ordered but were not, a list of materials that were expected but were not supplied, and materials arriving to the site which are incompatible with the purchase order. Accurate positioning of each construction resources will be displayed on a GIS map, and information of each resource can be queried and will be analyzed by portal system. For example, by using functions in a GIS system, the central station can get the current location of a material and estimate the travel time of them before it arrives at the predetermined construction site. This system guarantees the availability of right materials in the right quantity at the right place when they are needed, reducing the time spent searching for materials and assessing inventory status, and decreasing surplus and waste of materials are other benefits of utilizing the proposed system. For example, the system prevents materials from potentially being misplaced. Thus, it prevents ordering materials when they already exist on site. In addition, the system permits ordering materials if the inventory level of them reduces below minimum when the work package start date approaches. Deploying any automated data collection process in construction management requires various tags including prefabricated tag, bulk material tag that need to be attached to their invoice, tools tag that attach to each of them to represent their attributes, equipment tag, human tag that would be active RFID tag, which have longer reading range and can act as self-signaling tags, and space tags that attach to any element of space to represent the three-dimensional positions of the point which tag is attached. Types of information that need to be stored on the tags or remote databases could be divided into following groups. Identification-related information such as object ID, serial number, or production number. Task-related information such as warranty information, handling, and installation instructions and details. Status-related information such as current status and spatial information of the item. Operation-related information such as maintenance. An electronic exchange of information is created in this research, which provides real-time information and wireless communication among all players such as upstream parties, such as material suppliers, and downstream parties such as contractors. The proposed system is automatic, thus reducing the labor cost and eliminating human errors associated with data collection during construction by providing timely and faster information flow with greater accuracy amongst the construction site and off-site office. It can dramatically improve the construction management activities, which also lead to keep cost and time under control in the construction phase. It could improve working efficiency and minimizing errors, have a modern, automated and reliable management system, efficient information management, improve the effectiveness of data exchange, reducing the cost of information transfer, accurate collection of data, timely delivery of information and enable real-time reporting, eliminate unnecessary communication loops and secondary tasks. On the other hand, such intelligent system, by up-to-date information, permits real-time control enabling corrective actions to be taken, which can potentially facilitate great increases in productivity through efficiencies in coordination and allocation of resources and leads to reduction in cost and so on. It could reduce wasted materials through loss, damage, or oversupply, reduce business risk related to control of material, improve utilization of construction assets, significant reduction in laydown yard size, improve productivity, operational efficiency, improved material locating and movement efficiency, and reduced number of missing components. Also, it could improve inventory accuracy, reduce manual data entry for location management, and eliminates need for inventory audits. Thank you for your time and kind attention.